I went ahead and decided to improve the JavaScript-based PID simulation. So one of the first things that I went ahead and did was that I added these 3 new buttons on the PID controller for P, I, and D. And so if you start the program normally, it'll go ahead and do a regular PID simulation. Now what you can do with these buttons is that if you select one of them, it will go ahead and disable that variable in the actuator calculation function. So if I go ahead and disable D, I will now have a PI simulation controller. And then here you can see the graph adjust accordingly to the loss variable now. And I can continue to deselect these and just have a proportional controller, or I can deselect all of them and have it just do nothing. And in order to get these back, I can go ahead and select the reset button, and I'll go ahead and re-enable these buttons again so that I can continue showing what the simulation would look like with that. And so the way I implemented this was that I added the 3 buttons in the HTML section at the bottom in the code, and then I went ahead and made sure to hide and show them when appropriate according to the mode, and adjust them when the simulation is stopped, starting, or if it is being continued. So as you can see, when it starts, they will all become disabled, and then if you continue, they will all become disabled, and make sure that they are still hidden. So the next thing that I did was that I went ahead and added a new graph statistics section. So if you click this button, it will allow you to view or hide the graph statistics. And so what this does is that it'll continue to output these specific statistics into this box. So the way this works is that if I start it again, it'll go ahead and show me the steady state error, the maximum value that's currently reached, the minimum value, peak time, trough time, the current slope, and the intercept when it intercepts the desired value. So essentially when it intercepts at the x-axis, so if desired is 100. So let me go ahead and set that back to normal. And then you can see that all of these values will adjust accordingly. And also with this window, there is a reset button at the bottom. So what this does is that if I decide to change this and I don't want to look at these statistics anymore, I can go ahead and select the reset button, and it'll set everything back to 0. But it won't change anything else with the controller. So if I continue, I can go ahead and continue recording all of these different values as I go along. And this is a pretty cool tool because it allows you to record different samples of data with this, as you can like reset these statistics each time and just see how it is whenever you change something with the controller itself. And so the way that I did this is that I went ahead and made a new image called stats table that's included here. And then I just added that into the code at the bottom, the same way that the controller is added in the beginning. So essentially, this whole section is for the statistics form or box. And so with this comes a new function, which is the update stats function. So what this does is that it'll go ahead and set each of these stats each time. It'll set the steady state, the min, the max, the peak, the trough, slope, and intercept, and all that. And so this is called every time after the update in the update system function. So you have the normal standard update system function, and at the bottom it'll call update stats and update it afterwards. And so here you can see all the different formulas that are used to calculate these specific things. And also there's a new function for the reset button called reset stats. Well, it will only reset the statistics here. The statistics also reset when you start over again. So That's the only other time that they will reset with the controller. Otherwise, the reset button here will do nothing to the graph statistics here, and the reset button here will do nothing to the controller up here. And other fixes include adding a wider range for the ball's weight and the fan power, and also adjusting the formulas within the plant function here, just visually. I didn't change anything with the code, but just so a user can have a better understanding of what the actual formula is and what it needs to calculate.